All right, so lesson 9 is called Clash of the Logs. And what we're going to do in this video is we're going to go through the warm-up and some of the activities, and then talk about the summary. So our warm-up says order these logarithmic expressions from least to greatest. Now, some of these we know, like an actual value, and it's a nice whole number. Others we're going to have to estimate. Now, we're not going to use a calculator for any of this. So I'm going to start with this one here, log base 6 of 1. We know the log of any base of 1 is equal to 0. Okay, so it doesn't matter what this base is. If it's log base anything of 1, this is 0. So I'm going to write that there. Then log base 4 of 15, 4 raised to what power equals 15? Well, we know that 4 to the second power is 16, and 15 smaller than this, so this has got to be really close to 2, but smaller than 2. Now we have the natural log of e, and remember we talked about how natural log of e is log base e, and if it's log base e of e, it's going to be just whatever exponent is up here, which is invisible 1. So this is 1. Then we have log base 100 of 10. So 100 raised to what power is 10? Well, 100, I'll write it somewhere else. 100 raised to the x power equals 10. Well, the square root of 100 is 10. So that means x must be the 1/2 power. So, because that's the square root. Remember, 1/2 power and square roots are the same thing. So this is equal to 1/2 because 100 raised to the 1/2 power is equal to 10. And then here we have log base 5 of 10. 5 raised to what power is going to give us 10? Well, we know 5 to the first power is 5, so this has to be bigger than 1. 5 to the second power is 25, so this has to be between 1 and 2. So between 1 and 2. But closer to 1 than 2 because like we're much closer to 5 than we are 25. So now if we order these from smallest to largest, 0 is the smallest one. So it's going to be log base 6 of 1. Then we have 1/2. So log base 100 of 10. Then we have 1 ln e. The ln of e is equal to 1. And then we have log base 5 of 10. And then finally, log base 4 of 15. So I didn't have to use the calculator for any of these. I estimated them. Ones that I didn't know for sure, I got a close approximation, and that was that allowed me to put these in order from least to greatest. Now on the next page, card confrontation, we're not going to do this just because it's hard to do this activity over video. So we'll talk about what was going to happen with this tomorrow. So we're going to go right to activity 2, logarithmic challenges. Now I'm going to walk through these, and my answer that I come up with is not the only right answer. There's multiple correct answers. So we're going to be using each of the given values only once, fill in the blanks to make the inequality true. So for letter A, log, and then I have the log base blank of a number is greater than log base blank of another number. So we want the left side to be bigger than the right side. So what we can do is if we do 2 and 16, 2 raised to what power is 16? That is 4. And if we do 4 and 8 here, okay, that's going to read as log base 4 of 8. And then we put the 8 here. So log base 4 of 8. 4 raised to what power is 8? Well, again, 4 to the first power is 4. 4 to the second power is 16. So this log right here is between 1 and 2, which 4 is bigger than anything between 1 and 2. So this is a valid statement. Again, it's not the only one. Then letter B, we have log base 3 of 8 is less than log base blank of blank. And then log base blank of 7 is greater than log base blank of blank. So firstly, this log right here, 3 raised to what power gives us 81? That's 4. 3 to the fourth power is 81. So I need to make the other side bigger than 4. Now, if we make our base 2 and the other number 18, 2 raised to what power is 18? Well, 2 to the fourth is 16. So that means that if I have 2 to the x equals 18, x has to be bigger than 4. So that is a viable answer for that first one. But now I've used up my 2 and 18. Okay, so now I have log base blank of 7 is greater than log base blank of blank. So if I go and put like the 4 here, and then let's see, let's put the 9 and 15. Let's do 15 and 9. Let's do that. This will be easier to see. So 4 to what power is 7? 4 to the first power is 4. 4 to the second power is 16. So that means this value right here is between 1 and 2. Now, this one, 15 to what power is 9? Well, 15 to the first power is 15. So my exponent, if I have 15 to some power equals 9, my exponent's got to be smaller than 1. So the left side is to be bigger than 1. The right side's got to be smaller than 1. That makes the inequality true. All right, now letter C. Log base 5 of blank is greater than log base 4 of blank. So what I would do here, and remember, we can only use anything once, and we have more stuff down here. Actually, I'm going to do the second one next because this is an equals. So we have to have two things that are equal for that second one. So we have log base blank of blank equals 3 times log base 5 of what? Well, I'm going to put the 5 there because log base 5 of 5, 5 raised to what power is 5, has got to be 1. So I have now 3 times 1, which is 3. So now I've got to make this left side equal to 3. Well, if I do log base 3 of 27, it becomes 3 raised to what power is equal to 27? 3 to the third power is 27. So this is also equal to 3. All right, so I've used this one, and that one. Now I want the left side to be bigger than the right side. Well, if I put log base 5 of 24, that's 5 raised to what power is 24? That's almost going to be 2 because 5 to the second power is 25. So this is close to 2. And then that means the 10's got to go here. we have log base 4, or 4 to some power equals 10. Well, that's got to be bigger than 1, but less than 2 because 4 to the second power is 16, but it's further away. It's not 1 away like the left side is. So that would be a viable answer. All right, the last one, it has three expressions here. We have log base 2 of blank equals log base 3 of blank. So what I noticed is that we have a 1/9 and a 1/4 here. If I put the 1/4 here and the 1/9 there, I have 2 to what power equals 1/4. So remember, if I want 2 squared to be 4, but then it goes in the denominator, I can bring this down as a negative exponent. So this is equal to negative 2 because 2 to the negative 2 is 1 over 2 squared, which is 4. So 2 to the negative second power equals 1/4. Then we have the same thing here, kind of, where we have, okay, 3 to the second power is 9, but it's in the denominator. So I want 3 to the negative second means 1 over 3 squared, which is 1/9. So this right side is also equal to negative 2. Now I have the natural log of something is greater than log base 8 of something, and then the ln of something is greater than log base blank of blank. Um, let's go and try, well, log base 8 of 8 to the 1/2 power, this is just going to equal 1/2. Again, we had talked about how if the base and the other number like that are the same, then it's going to equal that exponent. So that's equal to 1/2. So I want the left side to be bigger than 1/2. Well, if I do log base um, log base e or natural log of e, this is equal to 1. We saw that on the first slide or first page right here. Now the last one we're going to cheat a little bit because we have a 1. So log base anything of 1 is going to be 0. So it doesn't matter what the base is. This is going to be 0. And then if I put e to the second power right here, this is going to equal 2. And you could verify all of these with a calculator too, but we're trying to get into the groove of thinking our way and estimating these logs based on powers that we know. So the synthesis, we're not going to do that, but I do want to go and do um, try this. It says, which logarithmic expression has a greater value, log base 5 of 130 or log base 2 of 40? Well, log base 5 of 130, that means 5 raised to what power is 130? Well, 5 to the third power is 125, and 5 to the fourth power is 625. So this is going to be, a little bit over 3. Okay, but we don't know how close it is to 3. But we know it's going to be a little bit over 3, but less than 4. Then log base 2 of 40, that's 2 to what power equals 40? Well, 2 to the fifth power, 2 times 2 times 2 times 2, 5 times, is going to be 32. 2 to the sixth power is 64. So that means 2 to the either some number between 5 and 6. X has got to be around 5. Um, because 2 to the 5th power is 32. So if we think about it, 2 to what power would equal 40? That's got to be bigger than 5. So that means this log base 2 of 40 is bigger. And again, you can verify using the calculator. All right, so that's it for this video. Thank you for watching. Make sure to like it and subscribe.